Hey guys, today we're going to take you through question 1 on the second page of the handout. I'm going to start off by reading out the question. Today I'm going to take you through question 1 on the second page of the handout. So I'll start off by reading off the question. In a game there are n players, where n is greater than 2. Each player has a disc, one side of which is red and one side blue. When thrown, the disc is equally likely to show red or blue. So all players throw the disc simultaneously. A player wins if his disc shows a different color from all the other discs. Players throw repeatedly until one player wins.
Through the question, we are able to extract 3 information. 1 is that n is the number of players. 2 is that n has to be bigger than 2. And 3 is that players throw repeatedly until one player wins.
Question A. State the distribution of x. So according from the 3 important information we extracted, we know that the players throw repeatedly until one player wins. This information tells us that we have to use geometric distribution because we need x numbers of trials until one player succeeds.
B. Find P when x equals x in terms of n and small x. So now we have to figure out the probability of succeeding in the first trial. To succeed, we have to take into consideration of the number of players, which is represented by n, and the probability of getting a red or blue. So the probability of winning in the first trial is n. The number of players times 0.5, which is the success of getting one red. And you multiply these by 1.5, 1 divided by half, to the power of n minus 1. 0.5 to the power of n minus 1 is the probability of the number of players getting blue, which in this case we consider as the failure. And you multiply these out by 2. The reason why we times it by 2 is because the winning disc can let in both red and blue. Okay, so we organize it. So now we have the equation n divided by 2 to the power of n minus 1. So, but remember, this is only the probability of succeeding in the first trial, which is equivalent to P in a geometric formula. So now we know that P x equals x is equal to n divided by 2 to the power of n minus 1, which is the probability of success. Times it by the bracket 1 minus n divided by 2 to the power of n minus 1 bracket, and to the power of x minus 1. Remember, x is the number of trials.
C. Find the expectation of x in terms of n. The expectation of x is the mean. So we know that the expectation in a geometric distribution can be calculated by 1 divided by the probability of success. We know that the probability of success is n divided by 2 to the power of n minus 1. So we get 1 over n divided by 2 to the power of n minus 1. Therefore, we reverse the probability, which gives us 2 to the power of n minus 1 divided by n. And this is the expectation of x, which equals to the mean. Question 4D. Given that n equals 7, find the least number k such that px smaller or equal to k is bigger than 0.5. So now that we know that there are 7 players in the game, you have to find the probability of x that is bigger than 0.5. In this case, x has to be smaller or equal to k. So how do we tackle this question? First, we substitute n equals 7 in the formula. This gives us 7 divided by 2 to the power of 6 times brackets 1 minus 7 divided by 2 to the power of 6 close brackets to the power of x minus 1, which is equal to 7 divided by 64 times 57 divided by 64 to the power of x minus 1. So now what do we do with this? Well, now we have to find the value of k. This can be represented by 7 divided by 64 times brackets 57 divided by 64 close brackets 1 minus 1 to the power of 1 minus 1. This is the first trial. Then we have to add the second trial, the third trial, until we reach the kth trial. We know that the sum of all these probability has to be bigger than 0.5. So now we organize the probability in terms of sigma notation, which is represented on the screen. So what do we do now? Well, now we have to show our creative IB math thinking. We take the fraction 7 divided by 64 out. So now we're left with this sigma notation on the screen. Then we apply the formula of geometric sequence. Sum of a geometric sequence series is equal to A1, the first term of the series, times 1 minus r, to the power of n divided by 1 minus r. So A1, which is the first term, is equal to brackets 57 divided by 64, close brackets, to the power of 1 minus 1, which is equal to 1. We ignore this part. Then we deal with 1 minus r to the power of n. This is the numerator of the fraction. In this case, 1 minus r to the power of n is equal to 1 minus 57 divided by 64 to the power of k, because we know that r is equal to 57 divided by 64. Now we look at the denominator, 1 minus r. 1 minus r is equal to 1 minus 57 divided by 64. Okay, we now have a complete equation. 7 divided by 64 times 1 minus 57 divided by 64 to the power of k divided by 1 minus 57 divided by 64. We cancel out 7 divided by 64 and 1 minus 57 divided by 64. Therefore, the remaining part of the whole fraction is 1 minus 57 divided by 64 to the power of k. We know that the answer to this equation must be bigger than 0.5. Therefore, 57 divided by 64 to the power of k must be smaller than 0.5, which is represented by the notation 57 divided by 64 to the power of k smaller than 0.5. Now we take log on both sides. K log 57 divided by 64 is smaller than log 0.5. So k is bigger than log 0.5 divided by log 57 divided by 64, which is equal to 5.98. So k must be an integer. So that k has to be at least 6. Thank you for watching. Hope you enjoyed it.